Good morning, everybody. I'm here today to talk a little bit of science with you. We have been discussing over the last few days heredity or genetics, or the study of genes and the way that genes can be inherited from parents to offspring. So some of the things that we've discussed that can be inherited from parents are eye color, hair color, and height. These things are sort of obvious things that are inherited from our parents. So the father of genetics, or who we consider to be the father of genetics, is Gregor Mendel. Gregor Mendel studied the pea plant. He realized that, on average, 3 out of every 4 pea plants grew to be tall. That's because the tall gene, or the tall allele, was the dominant trait, and the short gene, or the short allele, was the weaker of the traits. Okay. Later came along another scientist, Reginald Punnett, who continued working with the study of genetics, and he came up with what's known as the Punnett Square to sort of reinforce the idea that 3 out of every 4 pea plants that grew were tall, and 1 out of 4, or 25%, were short. So I'm going to do a couple of Punnett squares with you today, and these Punnett squares are discussing eye color. So first we're going to begin here, okay? The tall B, the big B, the capital B, represents brown eyes, and the lowercase b represents blue eyes. So when you are born, you inherit 2 alleles, or genes. The allele is the way that the allele is sort of like the flavor of ice cream that you can get, vanilla and chocolate, or strawberry, or mint chocolate chip. So brown is one flavor, blue is the second flavor. So again, the big B stands for brown, and the little b stands for blue. These are alleles that we are discussing. So alleles are the variation in genes, for example, brown, blue, green, and hazel. Now, brown is the most dominant, okay? Blue, green, and hazel, they are all recessive genes, okay? Let's begin here, where we're going to look and see, okay? Up here would represent a mother, and over here would represent a father. Now, this could be reversed. It doesn't matter where you put the mother or where you put the father. So let's imagine that you received a brown allele and a blue allele from your mom, and a brown allele and a blue allele from your father, okay? Then we're going to sort of like cross multiply. So we're going to put the B and the B together here. That's one way that your eye color can come out. You would get both alleles as brown. Obviously then, you'd be born with brown eyes. Now, let's cross capital B with the lowercase b. Okay, since the brown eyes, the big B, are dominant, and the little b, the blue, are recessive, if you were born with 1 and 1, you would be born with brown eyes. Okay, now let's cross here, brown and blue. Again, you'd get a big B and a little b. The brown is dominant, so the brown, the big B, would represent brown, the little b would represent blue, and you would be born here. Even though you had both alleles, you'd be born with brown eyes. Now, the only way that you could be born with blue eyes would be is if you received these 2 alleles. 2 blue represents 2 lowercase b's represent the blue. You would be born with blue because you would not be getting the brown allele from either parent. Okay, so it's sort of like they call it the genetic lottery. Okay, because it could happen any which way. But anyway, this represents, okay, this would be brown, 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 blue. Okay, this shows the 3 out of the 4, or the 75% chance that you'd be born with brown eyes, and only 1 out of 4, or the 25% chance that you'd be born with blue eyes. So again, going back to the tall versus the short pea plants, it represents the same thing. The dominant trait was 75% of a chance to come out, and only 25% of a chance to come out blue. Now, what's even more interesting, we're going to do another one. Okay, here, as you can see, there's only one brown allele. All the other 3 alleles are blue, which is the recessive trait. Now you would think, wow, okay, that means I have 3 out of 4 chance, 75% chance to be born with blue eyes. Not so. So here we're going to begin doing our crossing again. We have a capital B, which is brown, and a lowercase b, which is blue. But remember that when you get a brown and a blue allele, that the brown, the dominant gene, takes over and controls the trait that you receive. Okay, let's go here. A big B with a lowercase b again. Again, in these 2 cases, even though you have that blue gene in your body, you are born with brown eyes. Now, what's really interesting is that if you had children, even though you have brown eyes, they could be born with blue eyes. That happened to my father. He's the only one in the family that has blue eyes. So even though his parents had brown eyes, somehow he got that 1 out of 4 chance to be born with blue eyes. Anyway, back here. So far, both chances come out brown. Now we'll cross the recessive with the recessive, and in this case, you'd be born with blue eyes, and the same thing here, you'd be born with blue eyes. So even when both parents carry 3 out of 4 alleles as blue, there's only a 50% chance, or 2 out of 4, not 3 out of 4, to be born with blue eyes, and also a 2 out of 4 50% chance to be born with brown eyes. So this explains why that 79% of the world has brown eyes. That's near 80%, or 8 out of every 10 people, or 80 out of every 100, or 800 out of every 1,000 have brown eyes. These Punnett squares help to explain that. All right, I hope this helped clarify some of the things we've learned with Punnett squares, and I'm going to ask you to just answer a couple questions about that today, and that will be it for your science. So have a great day.